Welcome back. We're continuing to talk about piecewise defined functions. In our last video, we had a piecewise defined function that we graphed, and then we found the domain and range. In this video, we are going to go the other direction, and we have a piecewise defined function that we are actually going to write the equation for. So we are going to write that piecewise defined function. So when we are working through this process, the first thing we want to do is we want to identify the domains of our different pieces. So I am actually going to label my three pieces. So this piece of my graph is part A, this I'm going to call part B, and this I'm going to call part C. And I'm going to kind of work on these three pieces separately, and then I'm going to put them into my format. And so what that looks like is I am going to write this function as f of x is equal to, and then I am going to have the rule and the domain for that rule. So I need to come up with the domain of the rule for each part as well as the rule. And so I am going to have for part A, B, and C. So I need three different domains and three different rules. So I'm going to first start by looking at part A. So when I look at part A, I'm going to look for the domain of part A. And part A, it looks like, here's my number line. I have -2, here's 0. It's got an open circle at -2 and shading to the left. So my domain here, I'm going to write as x is less than -2. I'm not going to write this in interval notation because I tend to put it not in interval notation here. So if x is less than -2, that's my domain for part A. Now I need to find the rule. So this means I need to go back and think about how to write an equation of a line. So this passes through the point -3, -2, and it also seems to pass through 1, 2, 3, 4, 5, -5, 0. So I am going to use point slope form. So that is y minus y1 is equal to m times x minus x1. So starting with this, I need to find my slope. So my slope is y2 minus y1 over x2 minus x1. So that's going to give me 0 minus -2 over -5 minus -3, which is 2 over -2, which is -1. So I'm going to use this point. So I'm going to have y minus 0 is equal to -1 times x minus -5. So y is equal to -1 times x plus 5. Y is equal to -x minus 5. So my rule here is -x minus 5 for that domain. So my piecewise defined function, if I have an x value in this range or in this domain, I will use this rule. Okay, so now I'm going to look at part B. So for B, I'm going to start by looking at the domain. And for this domain, I see I've got -3, and I have a shaded circle here and an open circle at 1, shading in between. So this looks like -3 is less than or equal to x is less than 1. So -3 is less than or equal to x is less than 1 is my rule for portion B of this graph. So now I'm going to continue, and I am going to write the rule. So this passes through the point -3, 4 and 1, 4. So when I find my slope, I get 4 minus 4 over 1 minus -3. I get a slope of 0. This is a horizontal line. And if we remember Hoyvux, horizontal, 0 slope, y equals. So this rule is just y is equal to 4. So we don't include the y equals, we just write 4. So when we're writing the rule, we're just writing the right-hand side of that rule. Okay? So now I'm moving on to part C. So for C, I'm looking at the domain, and I have 1. So let's mark 0 on here. And I have a shaded circle at 1 right there, shading to the right. So this is going to be x is greater than or equal to 1. So my rule for that third portion is x is greater than or equal to 1 for the domain. Now let's find the rule. So this passes through the points 1, 5, and 2, 6. So starting with my slope, I get 6 minus 5 over 2 minus 1. That gives me 1 over 1. So I'm going to go with this. Y minus 5 is equal to 1 times x minus 1. So y is equal to x minus 1 plus 5. Y is equal to x plus 4. So this rule is x plus 4. So now this is my piecewise defined function that creates this picture.